Most visceral organs are innervated by both the sympathetic and parasympathetic divisions of the autonomic nervous system. Normally, both divisions are partially active, meaning most visceral organs are usually receiving signals from both of these divisions. Organs usually receive signals from both, which provides a type of dynamic antagonism, constantly working to maintain homeostasis. Usually, one division or the other will predominate at any given moment in time, but then the other will come back to predominate later. That's this dynamic kind of antagonism. Occasionally, the two systems will work in a cooperative kind of way. If we take a look at the major organs of the body that receive signals from the autonomic nervous system, we can see that they normally have antagonistic kinds of effects. If we look at the salivary glands, the parasympathetic nervous system stimulates the secretion of watery saliva, whereas the sympathetic stimulates the secretion of thick, viscous saliva instead. If we look at the heart, the parasympathetic nervous system decreases heart rate, whereas the sympathetic nervous system increases heart rate. We can see this same pattern for most organs that are innervated by the autonomic nervous system, like the gallbladder. If the gallbladder is receiving a signal from the parasympathetic, it excites the gallbladder to expel bile. If it receives a signal from the sympathetic, it inhibits the gallbladder. The gallbladder is relaxed and it does not expel bile. It's also important to note that many organs are receiving signals from the sympathetic nervous system, but don't receive any innervation from the parasympathetic. Sometimes, the sympathetic and parasympathetic sides of the autonomic nervous system work in a cooperative kind of way. The best example of cooperative effects are found in the external genitalia, where the parasympathetic nervous system stimulates blood vessels to dilate, and it causes an engorgement of external genitalia like the penis or the clitoris. Whereas the sympathetic system stimulates ejaculation or vaginal contractions during intercourse. The sympathetic nervous system also has unique roles where it works without the parasympathetic system. The adrenal medulla, the sweat glands, the erector pili muscles of the skin, the kidneys, and most blood vessels in the body only receive innervation from the sympathetic division of the autonomic nervous system. This means that the sympathetic division is largely in charge of thermoregulation for the body, cold sweats and prickles when we're afraid, increasing systemic blood pressure by contracting the tunica media of blood vessels, as well as increasing blood pressure by causing the release of a hormone called renin from the kidneys. That renin helps us retain water, and the retention of water further increases blood pressure.